Deep in the humid green heart of northern Colombia lies a place that doesn't look like the kind of spot where you uncover the remains of a prehistoric giant. It's not a gleaming lab or a carefully marked archaeological site. It's a coal mine, hot, noisy, and full of the smell of earth and fuel. In the early 2000s, a team of workers digging through layers of ancient rock stumbled upon something unusual. Instead of more coal or broken bits of plant fossils, they found smooth, curved pieces of bone, buried deep within the black earth. At first, no one really knew what they were looking at. The bones were too big to belong to any local animal. They weren't shaped like the limbs of mammals or the shells of turtles. They were long and round, like pieces of a spine, but so massive that they didn't seem real. When scientists arrived to examine the find, they immediately knew they had stumbled onto something extraordinary. Bit by bit, vertebra after vertebra was uncovered from the layers of rock. Each piece was carefully labeled, wrapped, and transported. What they found was not just a single fossil, but the remains of a creature unlike anything alive today. As the bones were cleaned and studied in laboratories, the team realized they were looking at a snake. But not just any snake. These vertebrae belonged to a creature that dwarfed every modern species. It wasn't just longer, it was thicker, heavier, and more powerful than any serpent humans had ever documented. The coal mine itself turned out to be a window into a forgotten world. Millions of years ago, long before humans, before ice ages, before modern forests, this place had been a swampy, tropical jungle. Trees with broad leaves towered over shallow waters. The air was hot and damp, like a greenhouse turned up to its highest setting. Strange creatures moved through the undergrowth and along the muddy banks. It was in this world that Titanoboa lived. Its bones had been trapped and preserved under layers of sediment, protected through time, waiting for the day when modern hands would dig them out. The discovery wasn't made by accident alone. Paleontologists had been searching coal mines like this one because they knew the region had once been rich with life after the extinction of the dinosaurs. These layers of rock date back to the Paleocene epoch, about 60 million years ago, a crucial time in Earth's history. Dinosaurs were gone, wiped out by a massive extinction event, and new creatures were beginning to take over. The world was hot, wet, and wild. By exploring mines, researchers hoped to find evidence of how life rebounded after catastrophe. They didn't expect to find the largest snake that ever lived. Imagine the moment the scientists first laid the vertebrae side by side. Modern anacondas and pythons have vertebrae that can fit in the palm of your hand. These, on the other hand, were the size of dinner plates. One by one, the pieces revealed a creature that may have stretched over 40 feet in length, longer than a city bus. Just to picture that is almost surreal. A snake so large that if it moved through a forest today, it could wrap around a car. Its body would have been thick like an oil drum. And yet, for millions of years, it lived hidden beneath the surface of the earth, known only to the rock that held its bones. The jungle setting of the discovery added to the sense of mystery. Workers described the heat and humidity as almost suffocating. The mines were surrounded by thick, tangled vegetation that seemed timeless. It's easy to imagine that if you stood quietly at the edge of that mine, listening to the buzz of insects and the rustling leaves, you could almost believe that Titanoboa was still out there sliding silently beneath the surface. The scientific team, led by experts from the Smithsonian Tropical Research Institute and local institutions, carefully mapped out the layers of rock where the fossils were found. They recorded the exact position of every bone, knowing that the way the snake was buried might reveal clues about how it lived and died. Paleontologists work slowly, patiently, like detectives at a centuries-old crime scene. Each brushstroke, each small scrape of a tool brings back a piece of history. What made this discovery even more astonishing was that Titanoboa wasn't found alone. In the same layers of rock, the team found fossilized remains of giant turtles and prehistoric crocodile-like creatures called dinosaurs. These animals shared Titanoboa's world. Their presence suggested a rich ecosystem, full of interactions between predators and prey. Finding all of these fossils together painted a vivid picture of a lost tropical paradise where enormous creatures thrived. The name Titanoboa came later. Titan evokes something mighty, almost godlike, while boa connects it to the modern family of large snakes. It was a fitting name. When the scientific papers were published and the news spread, Titanoboa captured the public's imagination. Headlines around the world announced the discovery of a snake that could swallow a crocodile whole. Museums recreated its massive skeleton. Documentaries featured animations of it gliding through ancient swamps. People were both fascinated and unsettled by the idea that such a creature had once been real. But before all the media buzz, before the documentaries and displays, it started with a quiet moment in the Colombian jungle. A worker digging in the heat, a paleontologist brushing away coal dust, the slow reveal of vertebrae that told a story older than humanity itself. Titanoboa had slept in the ground for millions of years, and now, at last, it had been found. Standing at the edge of that mine, surrounded by jungle and echoing machinery, you can almost feel the weight of time pressing down. It's strange to think that beneath our feet, the earth still holds so many secrets like this one. Entire worlds buried and waiting. Titanoboa's discovery wasn't just about finding a big snake. It was about opening a door to an era most of us can hardly imagine. A time when heat, humidity, and evolution came together to create something both monstrous and majestic. This was the beginning of Titanoboa's modern story. A few pieces of ancient bone had started a chain reaction, a wave of curiosity, research, and wonder that would ripple across the world. From that quiet coal mine in Colombia, the legend of Titanoboa began to rise once more. When the first reports about the fossil snake surfaced, the scientific community reacted with a mix of excitement and disbelief. A snake longer than a city bus? Vertebrae the size of dinner plates? It sounded almost mythical, like something out of a legend rather than a paleontology journal. Yet as the research progressed, the picture became clearer, and what emerged was not a myth at all, but a real creature that lived around 60 million years ago. Titanoboa was not just large, it was record-breaking. Based on careful analysis of its fossilized bones, scientists estimated that Titanoboa could grow up to 42 or 43 feet in length, weighing more than a ton. That made it the largest snake ever known to have existed, far surpassing the biggest modern anacondas and pythons. The measurements alone are enough to make anyone pause. Imagine a snake that could stretch across half a basketball court, its thick body sliding silently through warm, swampy waters. Its head would rise above the reeds like a living periscope, its tongue flicking slowly in and out as it sensed the movements of prey nearby. If it decided to coil itself around something, there wasn't much that could resist. The fossils revealed a creature built for power, with thick vertebrae that supported incredible muscle mass. This wasn't a fragile, delicate serpent. This was a living engine of strength, adapted perfectly to its environment. When paleontologists examined the vertebrae in detail, they noticed that their shape and structure resembled those of modern boa constrictors. That meant Titanoboa likely used constriction to kill its prey, wrapping its enormous body around animals and squeezing with enough force to stop blood flow and crush bones. But there was something even more intriguing. The sheer size of the vertebrae suggested that this snake didn't just live on land. Its build was ideal for an amphibious lifestyle, moving slowly but steadily through warm, shallow waters. Like a massive anaconda, it likely spent much of its time partially submerged, blending into the swamp, waiting patiently for the perfect moment to strike. The researchers also found themselves asking a big question: how could a snake grow this large? Reptiles depend on external heat to regulate their body temperature. If the world had been the same temperature as it is today, Titanoboa probably couldn't have reached such immense proportions. But during the Paleocene epoch, the Earth's climate was dramatically warmer. There were no polar ice caps, and the tropics were more like vast greenhouses, hot, wet, and stable. This warm environment acted almost like a biological amplifier, allowing cold-blooded animals like Titanoboa to thrive at sizes impossible in cooler climates. For a long time, giant reptiles had been associated mostly with the age of dinosaurs. Titanoboa shattered that assumption. It lived after the dinosaurs were gone, proving that gigantism didn't disappear with them. In fact, this colossal snake ruled its world in a time when mammals were just starting to expand. It represented a link between two very different eras, one dominated by dinosaurs and the other by the ancestors of modern mammals. Its existence forced scientists to rethink what they thought they knew about post-dinosaur ecosystems. The excitement wasn't limited to scientists. When news of Titanoboa's discovery broke to the public, it spread quickly. Newspapers, television shows, and documentaries couldn't get enough of the idea. There's something about giant creatures that captures human imagination in a way few other things can. People love to picture themselves standing next to a creature from another world, comparing their tiny size to the sheer scale of a prehistoric giant. Museums built life-sized reconstructions of Titanoboa's skeleton, letting visitors walk alongside its massive frame. The sight was enough to make anyone feel a little shiver, not from fear, but from awe. The fossil evidence told scientists more than just the snake's size. The shape of the vertebrae suggested how it moved. Titanoboa didn't slither quickly like a small garden snake. It would have moved in a slow, steady wave, its huge muscles pushing against mud and water. It wasn't built for speed. It didn't need to be. Its size alone made it the dominant predator of its ecosystem. Anything unlucky enough to cross its path probably didn't have a chance. The way Titanoboa's discovery challenged expectations also changed the way paleontologists approached the Paleocene period. For years, that era had been overshadowed by the drama of the dinosaur extinction that came just before it. It was often treated as a kind of quiet recovery phase for life on Earth. But Titanoboa proved it was anything but quiet. The ecosystems of that time were vibrant and full of remarkable creatures, just different from the ones that came before. In a sense, Titanoboa was the perfect ambassador for its age. As more fossils were studied, scientists realized that this wasn't just a single massive snake. There were multiple individuals found in the same area. That meant Titanoboa wasn't a lone monster, but part of a thriving species. This discovery helped researchers estimate its population density and understand how it might have interacted with other animals. A world where several Titanoboas lived side by side is hard to imagine today. Picture a swamp where more than one of these 40-foot serpents might glide through the water at any given time. The ancient jungle must have been a place of constant, quiet tension, every creature aware that somewhere in the water, a giant might be waiting. The process of naming Titanoboa was deliberate. Scientists wanted a name that conveyed its power and significance. Titan connects it to the legendary giants of Greek mythology, beings of immense strength who ruled before the Olympian gods. Boa ties it to the family of snakes we know today. Together, the name tells a story. A giant among snakes, a ruler of its swampy domain. For the paleontologists who spent years studying the fossils, Titanoboa became more than just an academic subject. It became a symbol of discovery, of the mysteries still hidden beneath the surface of the Earth. Every vertebra they cleaned, every measurement they took, was like piecing together a lost puzzle. And the more they learned, the more they realized that Titanoboa was not simply a larger version of today's snakes. It was something entirely unique, a creature perfectly shaped by its time and place. The world Titanoboa lived in was different, but the bones it left behind still speak clearly across the ages. They tell us about a serpent that reigned supreme not through speed or cunning, but through sheer size and strength. A serpent that belonged to a hot, wild Earth when forests were thick, crocodiles were massive, and mammals were just starting their slow rise. In that world, Titanoboa was the undisputed king. When the fossil bones of Titanoboa were first brought into the lab, they didn't look like much to the untrained eye. Just long, curved vertebrae, caked with ancient sediment, cracked in places from millions of years underground. But to a paleontologist, these bones were like pieces of a secret message, waiting to be decoded. Reconstructing a creature that no human had ever seen alive is like solving a puzzle without the picture on the box. Every vertebra, every measurement, every subtle curve of bone helps reveal the story of what this giant snake looked like, how it moved, and how it lived. The process began slowly. Technicians carefully cleaned the fossilized bones using tiny brushes and picks, removing bits of coal and rock that had stuck to them since the Paleocene epoch. This work required patience. One wrong move could damage a piece that had survived 60 million years underground. In some cases, the fossils were so delicate that they had to be stabilized with special resins just to keep them from crumbling. It was quiet, meticulous work, done under bright lab lights, far from the humid jungles where the bones were found. Once the bones were clean, the real detective work began. Paleontologists examined each vertebra, comparing them to those of modern snakes. Vertebrae can tell an incredible amount about a snake. The way the bones interlock reveals how flexible the body was. Their size indicates the overall scale of the animal. Subtle ridges and shapes hint at where muscles attached, helping scientists estimate how powerful the snake's movements would have been. Because no full skeleton of Titanoboa was found in perfect articulation, scientists had to reconstruct its body based on partial remains from several individuals. Luckily, snakes have hundreds of vertebrae, and their bones tend to follow predictable patterns along the spine. By measuring the shape and size of vertebrae from different parts of the body, researchers could build a digital model of the entire snake. Using computer software, they lined up the vertebrae one after another, adjusting for natural curves, estimating the length of the ribs, and creating a three-dimensional virtual skeleton. This digital reconstruction revealed just how astonishingly large Titanoboa really was. A snake's body length can be estimated based on the size of its vertebrae, and in Titanoboa's case, these bones suggested a creature more than 40 feet long. Its body was thick and muscular, not slender. If you stood next to it, its body would come up to your waist. Its head, though proportionally small compared to its massive body, would still have been the size of a dinner plate. But bones alone don't tell the full story. To imagine Titanoboa as a living creature, scientists also looked at its environment. They studied the fossilized plants, turtles, and crocodile-like creatures found in the same rock layers to understand the world it lived in. These details helped them estimate how Titanoboa might have moved, hunted, and interacted with its surroundings. Its body was likely adapted for an amphibious lifestyle, spending much of its time in warm, swampy waters. Its skeleton suggested a snake that moved with slow, heavy grace, pushing through muddy rivers with powerful, rhythmic motions. Artists worked alongside scientists to bring this creature to life visually. Paleo-artists specialize in reconstructing extinct animals, blending scientific data with artistic interpretation. They studied modern snakes, especially anacondas and boas, to understand how skin folds, muscle structure, and movement might have looked. They carefully scaled up these features to match Titanoboa's enormous size, imagining how light would reflect off its thick, scaly skin as it slid beneath the surface of ancient rivers. The result was both beautiful and unsettling, a giant serpent that looked real enough to imagine it breathing. Reconstruction also raised questions about color and texture. Fossils don't preserve snakeskin patterns, so no one knows for sure what Titanoboa looked like on the outside. Some reconstructions depict it with dark, mottled green or brown skin, like a modern anaconda, blending into the murky waters of its environment. Others imagine it with subtle striping or patterning, perhaps similar to pythons. While we may never know its exact colors, the patterns likely helped it stay hidden in its swampy home, allowing it to ambush prey with ease. Another important part of the reconstruction involved estimating Titanoboa's weight. Using formulas developed from modern snakes, scientists calculated that this massive serpent could have weighed more than a ton. That weight wasn't just for show. It gave the snake immense constricting power. A Titanoboa wrapping itself around a crocodile-like creature could have exerted crushing pressure, stopping its prey's heartbeat in seconds. This incredible strength, inferred from bone structure and size, gave scientists a new appreciation for just how dominant this snake must have been in its ecosystem. To share these findings with the public, researchers collaborated with museums to build a life-sized model of Titanoboa's skeleton. Visitors could walk along its 40-foot frame, tracing its spine as it curved through space. Standing beside the reconstructed skeleton, people often fell silent. It's one thing to read numbers on a page. It's another to stand next to a physical reminder of just how big life once was. The skeleton made the ancient world feel immediate and real, bridging the gap between distant prehistory and the present day. Reconstructing Titanoboa also had unexpected scientific benefits. By studying the relationship between its size and the ancient climate, researchers gained insights into the global temperatures of the Paleocene. Because snakes are cold-blooded, their body size is closely tied to environmental warmth. The fact that Titanoboa reached such immense proportions suggested that the tropics were much hotter back then than they are today. In this way, the giant snake became a kind of thermometer for Earth's ancient past, helping scientists better understand climate patterns after the age of dinosaurs. What started as scattered vertebrae in a Colombian coal mine slowly became a detailed portrait of a prehistoric giant. Through patient cleaning, careful measurement, digital modeling, and artistic vision, Titanoboa emerged from the shadows of time. Its reconstruction wasn't just about bringing back an extinct creature, it was about understanding a lost world, piece by piece, bone by bone. And perhaps most remarkably, the more scientists learned about Titanoboa, the more questions arose. How fast could it move through water? How did it hunt and reproduce? Did it face any predators of its own? These questions lingered in the lab air like echoes, waiting to be answered in future studies. Reconstructing Titanoboa was not the end of the story. It was only the beginning of seeing this ancient serpent not as a fossil, but as a living, breathing ruler of a forgotten age. The first thing that strikes almost anyone when hearing about Titanoboa is its size. 40 feet long, over a ton in weight, thicker than a grown man's torso. Those numbers sound almost abstract, like they belong to a creature from a fantasy novel. But when scientists began to compare Titanoboa to the largest snakes alive today, the scale of its size became even more impressive and a little hard to wrap your head around. Modern giant snakes, like the green anaconda and the reticulated python, are extraordinary creatures in their own right. The green anaconda, found in the rivers of South America, is considered the heaviest snake today. The largest verified individuals can reach around 20 to 22 feet in length and weigh over 500 pounds. The reticulated python, on the other hand, holds the record for length, with some exceptional individuals exceeding 26 feet. These snakes are powerful predators, capable of taking down deer, pigs, and even crocodiles. In their ecosystems, they are apex hunters, commanding respect and caution, but compared to Titanoboa, they almost seem small. Imagine a modern anaconda stretched out beside Titanoboa. Even the biggest living anaconda would be barely half its length. Titanoboa wasn't just a little bigger, it was on an entirely different scale. Its body was proportionally thicker, its vertebrae far larger, and its weight several times greater. If a modern snake can overpower a deer or a caiman, Titanoboa could have wrapped itself around prehistoric crocodile-like creatures and crushed them with terrifying ease. Its size alone would have made it the undisputed ruler of its swampy home. To help people grasp the scale, museums and documentaries often use everyday objects as comparisons. Titanoboa was longer than a standard city bus. If it coiled itself up in a circle, its body could form a loop big enough to park a small car inside. Lying next to a human, it would dwarf us completely. Standing in front of a life-sized reconstruction, people often find themselves instinctively stepping back. There's something almost primal about being faced with a creature so much larger than anything alive today. Scientists also compared Titanoboa's anatomy with modern snakes to understand how its massive size affected its behavior. One important difference is metabolism. Modern snakes, being cold-blooded, rely on external heat to regulate their body temperature. The larger the snake, the harder it is for its body to warm up. This means that Titanoboa could only have reached such enormous sizes in an environment consistently warm enough to support it. The Paleocene tropics, with their greenhouse-like conditions, were perfect for such a creature. Today's climates, even in the tropics, aren't warm enough year-round to allow snakes to grow to Titanoboa's size. Another fascinating comparison involves movement. Modern giant snakes are surprisingly agile in water. Anacondas, in particular, are slow on land but move gracefully through rivers, using their muscular bodies to push against the water with smooth, deliberate motions. Titanoboa likely behaved similarly, but on a grander scale. Its enormous bulk would have made rapid movement on land difficult, but in the buoyant environment of shallow tropical waters, it could glide with surprising ease. Imagine a 40-foot serpent slipping silently beneath a muddy river, its massive head rising just above the surface like a shadow. That was probably the world Titanoboa ruled. Size also affects diet. Modern giant snakes take down prey that matches their scale: large mammals, birds, or reptiles. Titanoboa's immense size meant it could target much larger animals. In the same rock layers where its fossils were found, scientists uncovered remains of huge turtles and crocodile-like reptiles. These creatures weren't small. They were large, armored animals in their own right. Yet they would have been vulnerable to a snake that could overpower them with crushing strength. Titanoboa likely relied on ambush hunting, lurking in the water until an unsuspecting prey creature came too close, then striking with a burst of power, coiling around its victim and squeezing until it could swallow its meal whole. One of the most striking things about Titanoboa's size is how it challenges our perception of what snakes can be. For many people, snakes are already a source of awe or fear, even at a few feet long. A 10-foot python is enough to make most people uneasy. Now multiply that by 4. Titanoboa wasn't just a bigger snake. It was a creature that existed on a scale that our modern world simply doesn't produce anymore. It is a reminder that Earth's past was full of life forms that don't fit neatly into our expectations. When scientists first announced Titanoboa's size, some skeptics questioned whether the estimates might be exaggerated. But the calculations were based on well-established formulas that compare vertebra size to body length in living snakes. The measurements were checked and rechecked, and the conclusion remained the same. Titanoboa was the largest snake ever discovered. This wasn't a matter of sensationalism. It was simply what the evidence showed. The discovery also gave researchers a rare opportunity to study how size affects ecosystems. A predator that large would have shaped its environment in significant ways. Just as modern top predators like lions or orcas influence the populations of their prey, Titanoboa would have played a central role in maintaining the balance of its swampy world. Its presence would have influenced where other animals lived, how they moved, and even how they evolved to avoid becoming its next meal. Perhaps most fascinating of all, Titanoboa's existence highlights how extraordinary Earth's history is. When we look at the largest animals alive today, elephants, whales, or giant snakes, they seem impressive. But they are just a fraction of what once existed. Titanoboa was living proof that, under the right conditions, nature can produce creatures so vast that they defy easy comparison. It's humbling to think that long before humans walked the earth, a snake longer than a bus ruled the rivers of ancient Colombia, gliding silently through a world that was warmer, wilder, and full of giants. Standing beside a reconstruction of Titanoboa, modern snakes seem like miniatures, and perhaps that's part of its enduring fascination. It reminds us that the natural world has always been capable of producing the extraordinary, and that the creatures we share the planet with today are just the latest chapter in a much larger story. Titanoboa was bigger than any snake alive now, not just in size, but in its ability to stretch our imaginations far beyond the limits of the present. One of the most important questions scientists asked after discovering Titanoboa was simple but profound. How could a snake grow that big? Reptiles depend on external heat to regulate their body temperature. Unlike mammals and birds, which can generate their own warmth internally, snakes rely on the environment to stay warm enough to move, digest food, and survive. The bigger a snake gets, the harder it is to keep its entire body at a suitable temperature. So, for Titanoboa to have reached more than 40 feet in length and over a ton in weight, the world it lived in had to be very different from ours. That clue led scientists to look closely at the ancient climate of the Paleocene epoch, the time just after the extinction of the dinosaurs, around 60 million years ago. What they found was fascinating. The world Titanoboa lived in was much warmer than it is today. There were no polar ice caps. Sea levels were higher, and the global temperature was consistently hot, almost like a greenhouse turned up to full power. The tropics, where Titanoboa was found, were especially warm and humid. Average temperatures there may have been around 30 to 34 degrees Celsius, 86 to 93 degrees Fahrenheit, far hotter than most tropical regions today. This warmth was exactly what a cold-blooded creature like Titanoboa needed. In today's world, snakes are limited in size partly because cooler nights or seasonal temperature changes make it difficult for their large bodies to maintain the heat necessary for survival. But in Titanoboa's world, the temperature didn't fluctuate much. It stayed hot all year round, providing a stable, warm environment that acted almost like a natural incubator. In such a climate, reptiles could grow to enormous sizes without the risk of freezing or slowing down too much. In fact, scientists were able to use Titanoboa's size to estimate ancient climate conditions. Because the body size of cold-blooded animals is closely tied to temperature, the discovery of Titanoboa became a kind of natural thermometer for Earth's past. By studying the relationship between the size of modern snakes and the temperatures of the environments they live in, researchers calculated that for Titanoboa to grow that large, the tropics must have been at least several degrees warmer than they are now. This provided one of the most compelling pieces of evidence for just how hot the Paleocene climate was. The warm climate didn't just benefit Titanoboa, it shaped entire ecosystems. The coal mines where Titanoboa's fossils were found were once dense, swampy forests full of life. Towering tropical trees with massive leaves grew close together, creating a thick canopy. The air would have been heavy with humidity, like a vast greenhouse. Rivers meandered through the jungle, slow and muddy, perfect for a giant snake to hide and hunt. Giant turtles and crocodile-like creatures thrived alongside it, supported by the lush vegetation and warm waters. It was a world designed for giants. The greenhouse conditions of the Paleocene were caused by high levels of carbon dioxide in the atmosphere. After the asteroid impact that wiped out the dinosaurs, Earth underwent a period of intense recovery. Volcanic activity and other natural processes released massive amounts of greenhouse gases, trapping heat and warming the planet. Unlike today's rapid climate changes, this warming happened over thousands of years, giving plants and animals time to adapt and thrive in the new conditions. Titanoboa was one of the species that took full advantage of this warmth. The climate also influenced Titanoboa's behavior. Warm temperatures allowed it to remain active all year, without hibernation or periods of dormancy. It could feed, grow, and reproduce continuously. The stable heat meant it didn't need to bask in the sun for long periods to warm up, as many modern snakes do. Instead, Titanoboa could spend most of its time lurking in the water or moving through the forest, always ready to ambush prey. Its body was adapted to a world where heat was never in short supply. This warm, swampy environment might sound uncomfortable to us, but for Titanoboa, it was perfect. Imagine standing in a dense tropical jungle where the air feels like a warm, wet blanket. The ground squelches beneath your feet, and every breath is thick with moisture. Around you, enormous ferns and trees crowd the landscape, their leaves dripping with condensation. The rivers are wide and sluggish, their surfaces broken only by the occasional ripple of something moving just below. That was the world Titanoboa called home, a world where warmth wasn't a luxury, but a constant. The climate clue also helped explain why Titanoboa doesn't have any modern relatives of similar size. As Earth's climate gradually cooled over the following millions of years, the stable, intense heat that allowed such giants to thrive disappeared. Polar ice caps formed, global temperatures dropped, and seasonal variations became more pronounced. These changes made it harder for reptiles to maintain the body heat required for truly enormous sizes. Giant snakes like Titanoboa couldn't survive in cooler, less predictable climates, and over time they disappeared, leaving only their smaller descendants. For scientists, the link between Titanoboa's size and ancient climate provided more than just an explanation for a giant snake. It offered a window into a world where the rules were different. The same Earth we live on today once operated under a different set of environmental conditions that made it possible for creatures like Titanoboa to exist. By studying these clues, scientists aren't just learning about the past, they're also gaining insights into how climate shapes life on Earth. Titanoboa's enormous size was more than a biological curiosity. It was evidence of a global system at work, a reminder that climate and life are deeply intertwined. Warmth created the perfect conditions for giants to flourish, and in return, those giants left behind fossils that now help us understand that ancient warmth. In a way, Titanoboa is both a creature and a climate record, its very bones carrying the story of a hotter, wetter world. It's incredible to think that by studying the vertebrae of a long-extinct snake, scientists can reconstruct the atmosphere of a world that existed 60 million years ago. But that's exactly what Titanoboa allowed them to do. Its massive size was like a fingerprint left by the climate itself, pressed into the stone for us to find millions of years later. And with that fingerprint, we can begin to understand not just the snake, but the world it ruled. A world where heat was abundant, forests were dense, and a giant serpent could glide through the swamps like a shadow. To truly understand Titanoboa, you have to picture the world it lived in, not as a collection of facts and numbers, but as a place you could walk through, hot, green, alive, and buzzing with life. 60 million years ago, northern South America looked nothing like it does today. Instead of bustling towns and sprawling farmlands, it was a vast tropical wetland, a landscape where rivers snaked lazily through thick jungle, and the air was so warm and humid it clung to your skin. It was a place of constant life, constant movement, and constant growth. Imagine waking up in this ancient world. The first thing you'd notice wouldn't be sights, but sounds. A low chorus of insects fills the air, a steady background hum that never stops. Huge dragonflies with wingspans like dinner plates glide between tree trunks, darting through shafts of sunlight that pierce the dense canopy. Frogs croak from every direction, hidden among massive ferns. In the distance, you might hear the splash of something heavy moving through the water, a prehistoric turtle dragging itself up onto a muddy bank, or perhaps something much larger, something sliding silently beneath the surface. The swamp is alive with plants unlike anything most of us see today. Towering trees rise high into the humid air, their trunks thick with vines. Massive leaves spread wide, collecting sunlight in the greenhouse heat. The ground is soft and damp, covered in layers of wet vegetation. Pools of still water reflect the deep green around them, occasionally broken by the ripple of a passing fish or the flick of a reptilian tail. It's the kind of place where you'd be soaked in sweat within minutes, where the line between water and land blurs until they become part of the same endless ecosystem. This was Titanoboa's kingdom. It didn't rule from a rocky cliff or a dry desert. Its domain was the swamp, a warm, muddy, slow-moving world perfectly suited to a massive, cold-blooded predator. Like modern anacondas, Titanoboa probably spent much of its time in water. Its enormous body, which would have been cumbersome on land, could move with surprising ease when buoyed by the swamp's shallow rivers. There, it could float almost effortlessly, conserving energy, waiting patiently. Its eyes and nostrils, positioned near the top of its head, would have allowed it to breathe and watch the surface while the rest of its massive body remained hidden below, like a living shadow. The rivers and wetlands of Paleocene Colombia were home to a variety of creatures. Fossils found alongside Titanoboa tell us that giant turtles, some as large as small bathtubs, glided through the water. These turtles weren't slow or defenseless. They were well adapted to their environment. But even their thick shells might not have saved them from a hungry Titanoboa lurking beneath the surface. There were also large crocodile-like reptiles called dinosaurs, long-snouted hunters that shared the same ecosystem. These animals would have competed with Titanoboa for food, but they also might have been prey themselves if they were unlucky. Fish were abundant too, thriving in the warm, nutrient-rich waters. Schools of prehistoric fish darted between submerged tree roots and fallen logs, providing a steady source of food for all the larger predators. Birds, though not as dominant as they would become later in history, flew through the trees and along the rivers, filling ecological niches left open after the dinosaurs' extinction. Small mammals were beginning to appear as well, scurrying among the undergrowth and trees. They weren't the dominant force they would eventually become, but they were survivors, adapting to a world still ruled by reptiles. The swampy world Titanoboa inhabited was stable in some ways, but also dangerous. The thick vegetation and still waters provided perfect cover for predators. A creature moving through this landscape had to be alert, always aware that something larger might be lurking just out of sight. Titanoboa didn't need to move quickly. It relied on its size, camouflage, and patience. It could wait in the same spot for hours, even days, its massive body hidden beneath the water. When the moment came, it could lunge forward with sudden, overwhelming force, wrapping around its prey and dragging it down without warning. The climate and geography also shaped the rhythm of daily life. Because temperatures stayed warm year-round, the creatures of this swamp didn't experience seasons the way animals do today. There was no cold winter to slow activity. Instead, life moved in a constant cycle of growth, feeding, and reproduction. Plants flourished in the abundant sunlight, animals fed on the plants, and predators like Titanoboa fed on the animals. It was a closed, thriving system, buzzing with energy in every direction. For Titanoboa, this world provided everything it needed: warmth, water, prey, and cover. It was perfectly adapted to its environment, and its environment, in turn, supported its enormous size. There's a certain poetry to that balance. The swamp was harsh in some ways, unforgiving to the unwary, but it was also a place of incredible abundance. Titanoboa didn't have to dominate every moment. It simply existed as part of a rich, interconnected system. Standing in that ancient swamp, if you could, would be overwhelming. The air would feel thick in your lungs. The sound of insects and distant splashes would surround you. You might catch glimpses of strange creatures moving just beyond the trees, their shapes half hidden by the humid haze. And beneath the surface of the water, somewhere unseen, Titanoboa would be there, coiled in silence, perfectly at home. This was not a world of deserts or ice, but of heat and water. A living greenhouse where evolution was experimenting with size and strength. In this place, Titanoboa didn't just survive, it thrived. Every inch of the swamp was shaped by the climate, the plants, and the creatures within it, And at the top of this rich, wet, tangled world was a snake so large it has no equal today, moving slowly and patiently through its swampy domain, a silent ruler of a forgotten time. In Titanoboa's world, survival was a daily dance between predator and prey. Everything in those steamy Paleocene swamps lived with the constant knowledge that something might be watching from beneath the water. And in that quiet, murky world, Titanoboa was the ultimate ambush hunter. It didn't need speed, it didn't need venom. It had patience, power, and a body built for silent strikes. Imagine the surface of a still, warm river. The water is thick with tannins from fallen leaves, dark and reflective like a sheet of glass. A few giant turtles paddle lazily nearby, their shells breaking the surface like drifting logs. Dragonflies skim low across the water, their wings catching the light. The air is heavy and still. There's no warning, no splash, no ripple, no sound. Just beneath the surface, Titanoboa waits. Its body is coiled loosely on the muddy riverbed, hidden among submerged branches and tangled roots. Only the top of its head breaks the surface slightly, nostrils and eyes peeking out just enough to breathe and watch. This is the posture of an ambush predator. Titanoboa didn't waste energy chasing. Instead, it waited for prey to wander close enough, its senses attuned to the faintest vibrations in the water. Modern snakes have specialized organs that detect subtle movements, and while we can't know for sure, Titanoboa likely relied on similar abilities, feeling its environment more than seeing it. When the right moment came, the strike was sudden and overwhelming. Titanoboa's enormous body surged upward and forward, breaking the surface in an explosion of water and muscle. It didn't need to aim perfectly. Its sheer size made escape nearly impossible for anything within range. With a powerful lunge, it could clamp its jaws around a limb or shell, then wrap its thick coils around its prey with breathtaking speed. Like modern boas and anacondas, Titanoboa killed through constriction. This wasn't a slow, drawn-out squeeze, it was rapid and precise. When a snake constricts, it doesn't crush bones like in old legends. Instead, each coil tightens with the prey's every breath, cutting off blood flow and oxygen. The victim usually loses consciousness within seconds. Titanoboa, with its immense strength, could have applied pressure far beyond anything alive today. A crocodile like Dinosaur or a massive turtle wouldn't have stood a chance once those coils closed in. Once the prey stopped struggling, the real work began. Titanoboa would have uncoiled slowly, adjusting its body to begin swallowing its meal whole. This might sound shocking, but snakes are built for it. Their jaws are teeth fused like ours. They can stretch and flex around prey much wider than their own heads. Titanoboa's jaws, scaled up to its enormous size, would have allowed it to swallow prey larger than most modern animals can imagine a snake eating. A crocodile-like reptile several feet long could have disappeared down its throat in a long, slow process. In the swampy world Titanoboa ruled, its hunting strategy was perfectly suited to the environment. The still waters muffled movement, the dense vegetation gave cover, and the warm temperatures kept it active. It didn't need to chase down prey across open ground, it just needed to be patient. Everything else eventually came to it. But Titanoboa wasn't the only predator in those waters. Fossil evidence shows that it shared its habitat with large dinosaurs, ancient relatives of crocodiles. These creatures were formidable hunters too, with long jaws filled with sharp teeth, built for grabbing fish or anything else that ventured too close. It's likely that Titanoboa and dinosaurs sometimes competed for the same prey. In some cases, they may even have encountered each other directly. Who would win in such a confrontation is hard to say. A large dinosaur could deliver a dangerous bite, but Titanoboa's size and strength gave it a serious advantage, especially in a surprise attack. Prey species had their own strategies for survival. Giant turtles used their thick shells as protection, but even that might not have saved them from Titanoboa's crushing embrace. Fish darted quickly through the water, but their speed was useless if they strayed too close to the snake's resting spot. Smaller reptiles and early mammals likely avoided the rivers altogether when possible, sticking to the forest floor or climbing trees to stay out of harm's way. The hunt wasn't always about massive battles, though. Titanoboa probably took smaller prey too, especially when younger. Juvenile snakes would have been far more vulnerable than adults and likely relied on smaller animals for food until they grew large enough to tackle bigger targets. As they matured, their prey choices expanded along with their size, eventually allowing them to dominate their environment. One of the most fascinating things about Titanoboa's hunting method is how little energy it probably used. Modern constrictor snakes are known for their ability to go long periods without eating after a big meal. A single, large prey animal can sustain them for weeks or even months. Titanoboa, with its colossal size, may have operated the same way. A successful ambush and a massive meal could have meant weeks of digesting quietly in the warm swamp, hidden among roots and mud, while its body slowly broke down its prey. If you were standing on the banks of a Paleocene river, you might never see Titanoboa hunt. There wouldn't be a long chase or a dramatic roar. There would just be stillness, followed by a sudden, almost invisible burst of movement beneath the water, and then silence again. A ripple, a splash, and something vanishing beneath the surface. It's the kind of hunting that happens quietly, without spectacle, but with deadly efficiency. In that way, Titanoboa was both a ghost and a force of nature. It didn't need to rule through constant motion or sound. It ruled by being the largest, strongest, and most patient creature in the swamp. Prey might not even realize it was in danger until it was far too late. That's the essence of an ambush hunter. Power hidden beneath still water, waiting for the world to come close. Titanoboa's hunting style tells us so much about its role in the ecosystem. It wasn't just another predator. It was the top of the food chain. Everything else in its environment lived, moved, and behaved in ways shaped by its presence. And all it had to do to maintain that dominance was lie in wait. In Titanoboa's swampy kingdom, it wasn't alone at the top. Sharing those hot, humid waters of Paleocene Colombia were fierce, crocodile-like creatures called dinosaurs. These were not the exact crocodiles we know today, but they looked and behaved in similar ways. Long, toothy snouts, powerful tails, and a lifestyle perfectly suited for ambush along riverbanks. For a long time, people imagined Titanoboa ruling its world uncontested, the absolute king of its murky domain. But the truth is more complicated. Titanoboa lived alongside other large predators, and that meant competition. Picture a muddy river at midday. The sun filtered weakly through thick layers of jungle leaves. A dinosaur rests half-submerged, eyes barely above the waterline, its long snout blending in with the debris floating on the surface. Its patience matches Titanoboa's. It waits for prey to wander close, a fish, a turtle, maybe even an unwary mammal coming to drink. But somewhere beneath the same stretch of water, a Titanoboa lies coiled, motionless, its huge body pressed into the mud. Neither predator knows exactly where the other is, but both are aware, in some instinctive way, that they are not alone. In this shared space, every meal mattered. Titanoboa relied on ambush, using its strength to overpower large prey and then digesting slowly over time. Dinosaurs, on the other hand, were quicker. They snapped up fish and medium-sized animals with sudden bursts of speed, relying on their jaws and agility rather than overwhelming strength. Sometimes their diets overlapped. A large turtle drifting too close to the riverbank could become the target of both, a silent underwater ambush from Titanoboa or a lightning strike from a dinosaur's jaws. Paleontologists have found fossil evidence of both Titanoboa and dinosaurs in the same geological layers, meaning they truly did share the same habitat. This has led to fascinating theories about how these two giants interacted. Some believe they maintained a kind of uneasy balance, Titanoboa being larger and stronger, probably dominated the deeper, slower parts of the river where it could wait patiently for big prey. Dinosaurs may have preferred shallower areas, using their speed to catch fish and smaller creatures. Like many predators sharing territory today, they likely avoided direct confrontation when possible. After all, a fight between such powerful animals could be dangerous for both sides. But there must have been moments when their paths crossed in more dramatic ways. Imagine a dinosaur dragging a struggling fish to the riverbank when, suddenly, the water behind it erupts. Titanoboa's massive body lunges forward, wrapping around the crocodile-like creature with frightening speed. In seconds, the dinosaur finds itself in a deadly embrace. It thrashes, biting and twisting, but Titanoboa's coils tighten with unrelenting force. In this kind of encounter, the snake's size would have given it the upper hand. Even a large dinosaur would have struggled to escape once caught. Of course, the opposite might have happened too. A younger or smaller Titanoboa could have been vulnerable to a sharp, crushing bite from a dinosaur's jaws. These predators were no pushovers. They had evolved to survive in a tough world, with powerful muscles and rows of conical teeth designed to grip and hold. A well-placed bite could have injured a snake badly, maybe even fatally. It's entirely possible that both creatures occasionally hunted one another when the opportunity arose, depending on size, surprise, and circumstance. This rivalry likely shaped their behavior over generations. Titanoboa may have become more skilled at stealth, keeping to deeper, quieter waters where its massive body could remain hidden. Dinosaurs may have developed keen awareness of their surroundings, avoiding areas where they sense the presence of something much larger lurking below. In ecosystems, competition often leads to specialization, with each species carving out its own niche to survive. This delicate balance allowed both predators to thrive side by side for thousands of years. Interestingly, the presence of these two apex predators also affected the prey animals. Large turtles, for example, had to be wary not only of a snake lurking silently below, but also of a dinosaur waiting near the surface. Fish swam in unpredictable patterns, darting between shallow and deep waters to avoid both sets of jaws. Early mammals that ventured to the river's edge had to be extremely cautious, listening for splashes, watching for ripples, knowing that death could come from either direction. The competition between Titanoboa and dinosaurs paints a richer, more complex picture of the Paleocene environment. It wasn't simply a world ruled by one colossal snake, but rather a dynamic ecosystem with multiple predators, each with its strengths and weaknesses. This balance likely helped maintain the health of the environment, preventing any single species from overwhelming the system. Over time, climate changes would begin to reshape this world. Temperatures cooled slightly, ecosystems shifted, and some species adapted better than others. While Titanoboa's immense size made it a dominant force, it also tied it closely to a very specific set of environmental conditions: warmth, humidity, and abundant prey. Dinosaurs, being more adaptable in some ways, may have survived longer in changing conditions, though eventually they too disappeared. When scientists study the fossils from this period, they aren't just looking at bones and scales. They're piecing together ancient rivalries, silent struggles that played out over centuries along riverbanks now turned to stone. The story of Titanoboa isn't just about a giant snake. It is about a complex web of life, where even the mightiest predator had to share its world with others equally determined to survive. So, in those hot Colombian swamps, Titanoboa may have been the biggest, but it was never truly alone. Just beyond its silent coils, the eyes of a dinosaur might have been watching, waiting, and hunting too. Their rivalry was written not in legends, but in the quiet ripples of prehistoric rivers, where strength, patience, and timing decided who ruled the moment. When people first hear the name Titanoboa, their minds often jump straight to dinosaurs. After all, it sounds dramatic. Titanoboa, the giant snake of prehistory. Its size rivals some of the smaller dinosaurs, and its presence feels like something straight out of a lost world. But one of the most fascinating facts about Titanoboa is that it didn't to live alongside the dinosaurs at all. By the time Titanoboa slithered through the steamy swamps of ancient Colombia, the dinosaurs had been gone for millions of years. Its reign came not during the Mesozoic, the age of dinosaurs, but during the Paleocene, the period that followed their sudden extinction. To understand why this is so interesting, let's travel back in time, not just to the Paleocene, but a little further. Around 66 million years ago, Earth experienced one of its most dramatic turning points. A massive asteroid struck near what is now the Yucatan Peninsula in Mexico, triggering a chain reaction of events that wiped out roughly 75% of all species on the planet, including nearly every dinosaur that wasn't a bird. Forests burned, skies darkened, temperatures dropped, and entire ecosystems collapsed. When the dust settled, the once dominant dinosaurs were gone, leaving behind an empty throne in Earth's food chains. Then, in the aftermath of destruction, a new world slowly emerged. The Paleocene was Earth's recovery phase, a time when ecosystems rebuilt themselves from the ashes. Mammals began to spread out, evolving rapidly now that their dinosaur predators were gone. Birds flourished, plants recolonized scorched landscapes, and in a warm, humid part of what is now South America, reptiles continued to thrive too. That's where Titanoboa appeared. Titanoboa lived roughly 60 million years ago, about 6 million years after the dinosaurs disappeared. This timing is important because it reveals something profound. Giant reptiles didn't vanish with the dinosaurs. They adapted. They found new niches to fill in the reshaped world. Titanoboa wasn't some leftover from the age of dinosaurs. It was a new kind of giant, perfectly suited to the Paleocene climate. The confusion is understandable. Movies and books often group all prehistoric creatures together as if they shared the same timeline. Dinosaurs, mammoths, saber-toothed cats, giant insects, and Titanoboa often end up in the same imaginary world. But in reality, these creatures lived in very different periods. For example, Stegosaurus roamed the Earth around 150 million years ago, while T-Rex appeared about 67 million years ago. Titanoboa lived long after both were gone, closer in time to humans than to the first dinosaurs. Think about that for a moment. Titanoboa's world is actually closer in age to ours than it is to the age of the great Jurassic and Cretaceous dinosaurs. When Titanoboa swam through its warm rivers, the planet was already in a new chapter. Mammals were evolving, forests were dense and tropical, and the rules of survival were different. It wasn't competing with towering carnivorous dinosaurs. It was part of a new wave of dominant creatures. This also means Titanoboa gives us a unique glimpse into how ecosystems recover after mass extinctions. While dinosaurs had ruled through sheer scale and evolutionary innovation, Titanoboa's world was one where other animals stepped up to fill the gaps. Reptiles like Titanoboa and dinosaurs continued their lineage in the tropics, while mammals diversified on land. Birds inherited the skies. Life didn't simply stop after the asteroid. It reshaped itself in new and surprising ways. Another fascinating point is that Titanoboa's existence helps scientists understand how climates evolved after the extinction. The Earth during the Paleocene was extremely warm, so warm in fact that reptiles could thrive near the equator at unprecedented sizes. If Titanoboa had lived during the time of the dinosaurs, it might have had more competition from massive carnivores. But in the Paleocene, with dinosaurs gone, it became the apex predator of its swampy domain. This distinction, Titanoboa not being a dinosaur, also helps explain its biology. Dinosaurs were a separate group of reptiles with unique skeletal structures and evolutionary paths. Titanoboa, on the other hand, was a snake, a descendant of earlier reptiles that had survived the extinction event. Snakes themselves are believed to have originated during the Cretaceous period, evolving from lizard-like ancestors. Titanoboa represents one of the early branches of large constrictors, showing how snakes could grow to astonishing sizes in the right conditions. The idea of Titanoboa living after the dinosaurs can be a little mind-bending, because we often imagine that the disappearance of dinosaurs marked the end of giant creatures. But the Paleocene proves that nature didn't stop experimenting with size. In fact, without giant predators like T-Rex dominating ecosystems, new creatures rose to prominence. Titanoboa was one of those. It wasn't a leftover from a dying age. It was a ruler of a new one. If you could stand in the jungles of Paleocene Colombia, you wouldn't see a world of towering sauropods or packs of raptors. Instead, you'd find thick, humid forests full of strange mammals, large turtles, ancient crocodile-like creatures, and among them, this enormous snake gliding silently through the rivers. Its size might make you think of the dinosaurs, but its time period would tell you otherwise. Titanoboa was something different, something that belonged to a world rebuilding itself. And in some ways, that makes Titanoboa's story even more remarkable. It wasn't just another creature living in the shadow of dinosaurs. It was proof that even after the greatest extinction events, life finds ways to surprise us. The age of dinosaurs may have ended, but the age of giants continued, in new forms with new rulers. Titanoboa, in all its silent, coiling power, was one of them. While Titanoboa glided through the hot, swampy waters of Paleocene Colombia, something else was stirring on land. The disappearance of the dinosaurs had left enormous gaps in the food chain, and a new cast of characters was slowly stepping into the spotlight. These were the mammals, once tiny, timid creatures that had spent millions of years living in the shadows of massive reptiles. Now, with the dinosaurs gone, mammals were beginning their rise, changing the face of the planet forever. Before the asteroid struck, mammals had already existed for a long time, but during the age of dinosaurs they were mostly small, nocturnal animals, scurrying through undergrowth, hiding in burrows, or creeping out at night to avoid being eaten by larger predators. They lived quiet, cautious lives. There were a few exceptions, but for the most part, they kept their heads down. The world was simply too dangerous for them to thrive in the open. After the extinction, everything changed. With the great predators and herbivores gone, there was suddenly space to grow, space to explore new habitats, and space to experiment with new forms. Over the next several million years, mammals spread into almost every ecological niche. Some became larger, taking advantage of the absence of giant dinosaurs. Others became specialized hunters, fast runners, or clever climbers. Forests expanded in the warm Paleocene climate, and mammals evolved to fill these lush new environments. In Titanoboa's world, mammals were not yet the huge, dominant creatures they would become later, but they were already on their way. Imagine small, furry animals darting between the dense roots of tropical trees. Some were early relatives of hoofed mammals, nibbling on soft leaves and fruits. Others resembled shrew-like insectivores, using their sharp noses and quick movements to catch bugs. In the trees, early primate-like mammals were beginning to emerge, swinging through branches and learning how to navigate a three-dimensional world. The climate of the Paleocene helped this explosion of diversity. Earth was warm, far warmer than today, and covered in thick forests in many regions. These forests provided shelter, food, and opportunities. Without giant dinosaurs trampling the underbrush or devouring everything in sight, mammals could flourish. Over time, they began to grow larger. Some became herbivores, others became carnivores, and their forms began to diverge rapidly. For Titanoboa, this rise of mammals might not have been immediately noticeable. Its diet likely focused on turtles, crocodile-like creatures, and large fish rather than mammals. But the two groups were part of the same ecological story. While Titanoboa ruled the rivers, mammals were quietly taking over the land. They were building the foundations for future ecosystems, ones that would eventually give rise to creatures like elephants, whales, and even humans. This period of mammalian expansion was a bit like the opening act of a play. The dinosaurs had exited the stage, and now a variety of new performers were stepping into the light. They were smaller, less dramatic than their predecessors at first, but their adaptability was their strength. Where dinosaurs had relied on size and power, mammals relied on flexibility, intelligence, and rapid evolution. One particularly interesting thing about this time is that mammals were experimenting with body plans in ways we don't often imagine. There were hoofed mammals with odd shapes, carnivorous mammals unlike anything alive today, and early primates exploring treetops. It was a world in flux, full of possibilities. Every branch of the mammalian family tree was just beginning to grow. Titanoboa's presence in this world is a reminder that evolution doesn't happen in isolation. While one group rises, another adapts. Mammals didn't suddenly dominate overnight. They grew and evolved alongside other survivors of the extinction event. In some regions, giant reptiles like Titanoboa remained the top predators. In others, mammals started to climb the ladder. Over millions of years, these shifting dynamics would reshape life on Earth. What makes this period especially fascinating is how different it was from what came before and after. Before, the world was ruled by dinosaurs, towering creatures that shaped every ecosystem. After, in the Eocene and beyond, mammals became larger and more dominant, producing animals like early elephants, massive herbivores, and powerful predators. But in the Paleocene, the balance was delicate. Reptiles like Titanoboa still held power in some places, while mammals were finding their footing in others. If you could walk through a Paleocene forest, you might not recognize most of the animals. They wouldn't look like the mammals we see today, but you would see hints of the future in their forms. The beginnings of hooves, the shape of a primate's face, the scurrying movements of small creatures destined to become something greater. And somewhere nearby, perhaps just out of sight, Titanoboa would be resting in a warm river, utterly unaware that the world around it was slowly shifting toward a mammal-dominated future. In a way, this chapter of Earth's history is both quiet and monumental. It lacks the drama of a dinosaur-filled landscape or the familiar animals of later periods, but it marks the moment when mammals began their climb. Titanoboa represents the strength of the ancient reptilian world holding on, while the mammals represent the future rising steadily from the shadows. Their paths didn't directly collide. Titanoboa likely wasn't stalking mammals through the forest, but they were both part of the same unfolding story. One was the giant of its time, a relic of the Earth's deep evolutionary past. The other was the newcomer, still small but full of potential. And slowly, over the ages, that balance would tip. The rise of mammals during Titanoboa's reign wasn't loud or sudden. It was quiet, patient, and unstoppable, just like the snake itself, waiting for the right moment to strike. Evolution works in whispers as much as in roars. And in those warm Paleocene forests, those whispers were shaping the future of life on Earth. The story of Titanoboa might sound like a legend passed down through generations, but everything we know about this massive snake comes from the ground, specifically from the fossils uncovered in a place that used to be a swampy paradise millions of years ago. The bones of Titanoboa don't just tell us about a single creature, they reveal details about an entire ancient world, locked in stone and waiting patiently to be read like pages of a buried book. The fossils were found in Cerrillon, a vast coal mine in northern Colombia. This place, now dry and scarred by mining operations, was once part of a tropical wetland ecosystem during the Paleocene. Deep beneath layers of earth and ancient plant matter, paleontologists unearthed vertebrae, massive, curved bones unlike anything they had seen before. Each vertebra was as large as a man's hand, far bigger than any snake vertebra found previously. As they carefully brushed away the layers of rock and sediment, a picture began to form. These weren't just big bones. They belonged to the largest snake ever discovered. Titanoboa's fossilized remains have given scientists remarkable insights into its size and shape. By comparing the vertebrae to those of modern snakes like boas and anacondas, Paleontologists estimated that Titanoboa measured around 42 to 47 feet long, longer than a city bus, and weighed over a ton. But the fossils did more than give us measurements. They opened a window into the environment the snake lived in. One of the most fascinating things about these fossils is how they help us understand ancient climates. Snakes are cold-blooded animals, meaning their body temperature depends on the warmth of their surroundings. Modern giant snakes like anacondas and pythons are limited in size by the temperature of their environment. If it's not warm enough, their bodies can't function efficiently at enormous sizes. So, when scientists found a snake as massive as Titanoboa, they knew it could only have existed in a very warm climate. By calculating the likely body temperature of a snake that size and comparing it to what would be needed to sustain its metabolism, fossils from Sarrajon didn't stop at snake bones. The same layers also contained remains of giant turtles, ancient fish, and crocodile-like creatures called dinosaurs. Together, these finds painted a detailed picture of a lush, swampy ecosystem where warm, shallow rivers wound through dense forests. The presence of coal itself, a product of compressed ancient plant matter, tells us that this area was once thick with vegetation, ideal for supporting a diverse web of life. The fossils also provide clues about Titanoboa's evolution. Snakes likely originated during the Cretaceous period, evolving from lizard-like ancestors. By the time Titanoboa appeared, snakes had already adapted to a wide range of habitats. Titanoboa represents an early branch of large constrictors, showing just how quickly snakes could grow and dominate ecosystems after the extinction of the dinosaurs. Its size demonstrates that evolution can produce giants relatively fast when conditions allow. Studying Titanoboa's fossils wasn't easy. Each vertebra had to be carefully removed, cleaned, catalogued, and compared with existing specimens. This kind of work can take years, requiring incredible patience and precision. Imagine sitting in a hot, dusty mine, slowly brushing away tiny grains of rock to reveal a curve of bone that hasn't seen the light of day in 60 million years. Every fossil is fragile, and one careless move can erase a piece of history forever. Once the fossils were prepared, paleontologists created detailed reconstructions of Titanoboa's skeleton. Using 3D scanning and computer models, they were able to estimate how the snake moved, how thick its body was, and how it might have looked in life. The image that emerged was astonishing. A snake as thick as an oil drum, gliding through ancient rivers like a living shadow. What's even more exciting is that fossils continue to offer new information as technology advances. Modern imaging techniques, chemical analysis, and scanning methods can extract details that earlier researchers might have missed. For example, chemical residues in fossils can sometimes reveal information about the plants and animals in the environment, or even the temperature of the water the creature lived in. Every time technology improves, scientists can return to these same fossils and learn something new. The fossils also remind us of how much remains undiscovered. Titanoboa was found by chance during mining operations. It makes you wonder what else lies hidden in the ground, waiting for the right eyes to find it. There could be even larger species, or creatures we've never imagined, locked away beneath layers of earth. Fossils are like time capsules, and Titanoboa's bones just happen to be some of the most spectacular ever opened. Another layer of mystery is that we still haven't found a complete Titanoboa skeleton. Most of what we know comes from dozens of vertebrae and a few skull fragments. Snakes have many vertebrae, so even a partial skeleton can provide a lot of information. But a complete specimen would give us even deeper insights into its exact shape, movement, and even behavior. Paleontologists continue to search the Sarrajon Formation for more clues, hoping to one day find that perfect fossil that ties everything together. Titanoboa's fossils are more than ancient bones. They're storytellers. They whisper details about climate, evolution, ecosystems, and the sheer power of nature to produce something both terrifying and beautiful. They remind us that Earth has been through many chapters, each one written in stone, waiting for us to dig it up and listen. In the end, the discovery of Titanoboa isn't just about finding the biggest snake that ever lived. It's about understanding the world that snake called home. Through these fossils, we don't just imagine, we know. And that knowledge connects us across millions of years to a time when giants slithered silently through swamps under a blazing prehistoric sun. When Titanoboa was first unveiled to the world, it didn't just capture the attention of scientists, it captured the imagination of millions of people. There's something undeniably fascinating about a creature that seems both real and mythological at the same time. A snake longer than a city bus, heavier than a car, gliding through ancient rivers. It sounds like something out of a movie. And in many ways, Titanoboa became exactly that. A modern legend, a star of documentaries, headlines, and popular culture. Before Titanoboa, the idea of truly gigantic snakes belonged mostly to folklore and exaggerated stories. Tales of enormous serpents have existed in almost every culture. Giant pythons in Southeast Asia, mythical dragons in Europe, feathered serpents in Mesoamerica, and massive river snakes in the Amazon. Many of these legends were rooted in real encounters with large snakes, exaggerated over time through retellings. But Titanoboa was different. This was no myth. It was real, fossilized proof that a snake of unimaginable size once ruled the earth. When scientists announced Titanoboa's discovery in 2009, the world took notice. News outlets ran dramatic headlines. The world's largest snake discovered. Monster snake from prehistoric times. Meet Titanoboa, bigger than T-Rex's worst nightmare. Images of reconstructed Titanoboa skeletons stretched across museum floors, giving visitors the shocking opportunity to stand next to something that seemed straight out of a monster movie. Documentaries quickly followed. One of the most famous was the Smithsonian Channel's Titanoboa, Monster Snake, which combined real science with cinematic storytelling. The program showed paleontologists uncovering the fossils, reconstructing the snake's body, and creating life-sized models to show just how enormous it really was. Viewers were amazed to see a snake thick as an oil drum, winding its way through lush green swamps, hunting crocodile-like creatures in dramatic slow motion. These depictions sparked the public's curiosity in a way few fossil discoveries do. Dinosaurs have long dominated the world of prehistoric fascination: T. Rex, Triceratops, Velociraptors. But Titanoboa offered something different. It wasn't a dinosaur. It was a reptile that lived after their extinction, showing that Earth's history didn't stop when the dinosaurs vanished. It was like discovering a secret chapter between two well-known parts of a story. Of course, popular culture did what it always does. It amplified. Movie posters and online fan art often depicted Titanoboa as a hyper-aggressive monster, attacking entire villages or wrapping itself around buildings. Some imagined it as a kind of super predator that could challenge dinosaurs, even though in reality they never lived at the same time. The name Titanoboa itself sounds like it belongs to a mythical creature, which helped it fit perfectly into the world of entertainment. But even beyond the exaggerations, Titanoboa left a deep impression. Museums around the world created exhibits featuring life-sized models of the snake. Visitors could walk alongside these enormous replicas, their eyes widening as they realized just how massive a real Titanoboa would have been. For children especially, it was both thrilling and a little scary, a reminder that Earth's past held creatures far more extraordinary than anything imagined in fiction. The fascination with Titanoboa also tapped into a very primal human reaction. Snakes have always evoked a mix of fear and awe. Even small snakes can make people uneasy. The thought of one large enough to swallow a crocodile or a person whole plays on that ancient instinct. But this time, it wasn't even a campfire story or a legend. It was science giving us a real creature that outstripped even our wildest snake myths. Interestingly, Titanoboa also influenced scientific conversations beyond popular media. Its discovery became a teaching tool for explaining climate change, evolution, and paleontology to the public. Because its size is directly linked to temperature, Titanoboa provides a tangible example of how climate affects the creatures that live in it. Teachers and documentary hosts used its story to explain ancient climates and how life adapts to environmental changes. It was a way to connect people emotionally to scientific concepts that might otherwise seem abstract. Online communities embraced Titanoboa too. Artists created stunning digital paintings of the snake hunting, resting, or coiling through forests. Amateur paleontology enthusiasts debated how it might have behaved, what sounds it might have made, if any, and whether something similar could ever exist again. It became a kind of cultural icon, a symbol of the wild, unpredictable nature of Earth's past. And, of course, the myths didn't stop. Once Titanoboa entered the public imagination, stories began circulating about modern sightings of enormous snakes in the Amazon or unexplored jungles. These stories have existed for decades, but now they were often tied to Titanoboa. What if one survived? What if it's still out there? Scientists, of course, have found no evidence of living Titanoboas, but the idea that such a creature once existed fuels these modern legends. Titanoboa's impact on modern imagination shows how powerful paleontology can be. A few vertebrae found in a coal mine turned into a global phenomenon. It reminded people that the Earth's history is filled with surprises waiting to be uncovered, and that sometimes the truth really is stranger than fiction. In the end, Titanoboa isn't just a prehistoric snake, it's a bridge between science and story. It lives in research papers and museum exhibits, but also in documentaries, conversations, artwork, and daydreams. It fascinates us because it's real, yet it feels legendary. It existed long before humans, yet it speaks to something very human, our deep curiosity about the giants that came before us. And perhaps that's the most remarkable thing about Titanoboa's modern legacy. Long after its species disappeared from the swamps of ancient Colombia, it found a new kind of life in our collective imagination, uncoiling silently from the rocks of time to slither into our stories, our museums, and our dreams. As the story of Titanoboa draws to a close, it becomes clear that this ancient snake's importance goes far beyond its jaw-dropping size. Yes, it was the largest snake ever discovered. Yes, it lived in a world that seems almost mythical to us now. Steaming jungles, giant turtles, crocodile-like predators, and sweltering heat. But Titanoboa's true legacy is not just that it was big. It's that it changed the way we understand Earth's history, climate, and the resilience of life itself. Titanoboa lived during the Paleocene epoch, a time of recovery after one of the most devastating mass extinctions the planet had ever experienced. Dinosaurs were gone, ecosystems were reshaping, and the world was entering a new chapter. Titanoboa wasn't a leftover relic. It was a sign of how quickly life can adapt and thrive in new conditions. Within just a few million years of the asteroid impact that ended the Cretaceous, Earth was home to a creature so massive it rivaled the most spectacular reptiles of the age before. Its existence is proof that nature wastes no time filling empty ecological spaces and that evolution is constantly writing new stories. But perhaps the most fascinating part of Titanoboa U.S. legacy lies in what it tells us about climate. Because snakes are cold-blooded, their size is directly influenced by the warmth of their environment. A snake as enormous as Titanoboa could only have survived in consistently hot temperatures. By studying its fossils, scientists were able to estimate ancient tropical climates in a way they couldn't before. Titanoboa became a kind of natural thermometer, offering direct evidence of just how warm the planet was 60 million years ago. This has modern implications. Today, as we face global climate change, understanding ancient climates helps scientists make more accurate predictions about the future. Titanoboa shows us that warmer worlds can produce larger reptiles, denser forests, and very different ecosystems. It's a reminder that climate shapes life in profound ways, and when the world changes, life changes with it. Titanoboa also expanded our understanding of snake evolution. Before its discovery, scientists didn't fully realize how quickly snakes could achieve gigantic sizes after the extinction of the dinosaurs. Finding Titanoboa revealed that snakes were not just surviving, they were thriving, competing with other large predators and dominating their environments. This challenged old assumptions about which groups of animals took the lead after the dinosaurs disappeared. Mammals were rising, yes, but reptiles like Titanoboa still held powerful positions in some parts of the world. In the public imagination, Titanoboa gave people something new to marvel at, something that wasn't a dinosaur but was every bit as awe-inspiring. Museums, documentaries, and classrooms used its story to spark curiosity about Earth's history. It showed that there are still incredible discoveries to be made, even in places we might not expect, like a Colombian coal mine. It inspired artists, storytellers, and scientists alike, weaving itself into the fabric of both science and culture. But beyond all that, Titanoboa's legacy is also humbling. It's a reminder of how vast and varied Earth's history is, and how small a slice of it we occupy. This snake lived and ruled tens of millions of years before humans ever appeared. It swam through rivers long gone, under skies that were warmer and thicker with moisture than anything we've known. Its world vanished without ever knowing us, and yet, through a few fossilized bones, it reached across time to tell its story. Standing before a life-sized model of Titanoboa in a museum, or looking at the delicate curves of its fossilized vertebrae, it's hard not to feel a sense of wonder. This was once a living, breathing creature, gliding silently through its world with no knowledge of the impact it would one day have on ours. It didn't roar, build nests, or leave behind monuments. Its legacy was written in the mud and preserved in stone, waiting for us to uncover it. Titanoboa reminds us that the Earth is a place of endless surprises. We often think of the age of dinosaurs as the pinnacle of prehistoric grandeur, but there were other ages, other giants, other rulers. Its discovery encourages us to keep exploring, to keep digging, to keep asking questions about what else might be out there, still hidden beneath layers of time. And perhaps the most beautiful part of its legacy is this: Titanoboa bridges two eras. It connects the world that came before the dinosaurs' extinction with the world that led to us. It's a symbol of continuity, of how life endures, adapts, and evolves. Long after the dinosaurs vanished, long before humans emerged, Titanoboa thrived. And now, long after its own extinction, it continues to inspire wonder. The real legacy of Titanoboa is not just its size or its fame. It's the story it tells about life's power to adapt, the climate's role in shaping ecosystems, and our ability to uncover and learn from the deep past. In that way, Titanoboa isn't just a prehistoric giant. It's a teacher, a reminder, and a symbol of the vast, interconnected history of life on Earth. And so, our quiet journey through the warm, ancient swamps comes to an end. Titanoboa's world may be gone, buried deep beneath layers of rock and time, but her story still whispers through the fossils left behind. She reminds us that life on Earth has taken many incredible shapes, some gentle, some fierce, and some so extraordinary they almost feel like legends. From the moment her massive body glided through the rivers to the day she disappeared from the planet, Titanoboa stood as a silent witness to a changing world. She lived in the warmth after catastrophe, thrived when others could not, and left a mystery that would take millions of years for humans to uncover. Maybe that's why her story feels both distant and strangely familiar. Because just like Titanoboa, the Earth is always changing. Species rise and fall, climates shift, and hidden worlds wait patiently to be found again. Thank you for joining me on this slow journey into prehistory. If you enjoyed this story, don't forget to like the video and subscribe so you won't miss more gentle tales from the past to help you drift into sleep. Until next time, rest well, and let the echoes of Earth's ancient giants guide you into peaceful dreams.